actually means. And it is not the button on your calculator. Okay. Let's go. How do we find the area of a rectangle? Have I been through grade 5? Yes, I have. How do you find the area of a rectangle? Length times width. And your teacher, probably in elementary school, said that length is the longer side and width is the shorter side, right? Of course, it does not matter because you are multiplying. And the order in multiplication doesn't matter. It doesn't affect the outcome because multiplication is what we call commutative. I will never make you write down the word commutative. I will never make you define the word commutative if you understand that 5 times 2 is the same as 2 times 5. Just like 2 plus 5 is the same as 5 plus 2. That is the commutative property. Okay? So, the area of a rectangle equals L times W. Right? We all were in grade 3. We all know that. Now, what if our rectangle is that very, very special rectangle that is a square? Is it still a rectangle? Yes, it is. Is it still area equals L times W? Yes, it does. But in a square, L and W are special. What makes them special? They're the same. W equals L. So do I need 2 different letters anymore? No. So LW really is LL or WW, which makes no sense. So we usually write something like S squared for side. Everybody good? That is why we call this symbol a square root. Because if we were drawing it out, it would make a square. 2 by 2, 4. 3 by 3, 9. What's the next one? 16. What's the next one? Okay, good. So, if you know the area of a square, how can you determine the length of each side? So if I tell you this area is 36, how do you know how big the side is? Yes? You would hit the button on your calculator, which is giving you a square root. Why do we call it a square root? Because of this. Everybody good? So, it will be 6. So the area equals the side squared, and the side equals the square root of the area. Is everybody cool? Yeah. Spectacular. This symbol is asking you to do something. This symbol, this particular symbol, is asking you to do something, but just this part of it is asking you to do something. I screwed that up. Sorry. This symbol is asking you to do something specific when it's written this way. It can be written other ways. Okay? This symbol is asking you to find 2 equal factors of the expression that it surrounds. Now, for you people, you're used to seeing a number in there, right? But math doesn't just use numbers. Math uses variables. Math uses symbols. Math uses a whole bunch of other stuff. So that is why I have said the word expression there. Because you are going to learn what to do with that when it is not just a number. Everybody good? Okay. Let us move on then. I didn't say it. I'm keeping you on your toes. How will I find the volume of a prism? Now, this you may not have done previously. Raj? Not if it's a prism. Right. Volume equals, well, let's keep it like grade 5. W, L. Width and length, right? And what is back here at the back of this prism? Well, that's another rectangle, right? Which means that rectangle went back this way a certain amount. Yes? That certain amount right there is a height. Because this rectangle repeats that many times. So it is LWH. Now, what if it is that very special prism that is a cube? X cubed. Volume equals LLL or WWW or HHH. And we shorten that because they're all the same. We give it one letter. S cubed. Everybody good? Yeah, all right. If you're provided with the volume, how can you determine the length of each side? Well, you're smart kids. Area was the square root of each side. So what must cube root? Volume equals side cubed. Side equals the cube root of volume. Yeah? Yeah. Now, this version of the symbol is asking me to do what? When it was that version, it asked me to find what? 2 factors. What's this version asking me? 3 equal factors of the expression under the symbol. Now that's got a name, but I'm not going to get to it yet. All right. The small 3 is the only difference. That is called the index. Please highlight it, underline it, put a Mrs. Bad Crumble cloud around it so it's included in your shape of the day. I don't care. Somehow get that word in your head. The index tells me the size of group of equal factors. We never write 2. Why do we never write the 2? Same reason we never write a 1 in front of an X. Because there is no smaller number I could put there, right? Factors need 2 at least, right? Because if I have 1 factor, what's it multiplying by? Nothing, right? So we never write the 2, but otherwise we always write the number. So if I have a 4, there's going to be 4 equal factors. If I have a 5, there's going to be 5. If I have a 6, it's going to be 6. Everybody cool? All right. Now, this is a little dodgy here. Because when we say perfect square, you guys are thinking of things like 4. Because the square root of 4 is 2. Right? What's the next one? 9. Because the square root of 9 is what? 3. Right? That's what you guys are thinking. And if I was doing cubes, cube root of 8 is 2. Cube root of 27 is 3. That's what you're thinking, yeah? And up until here, that's been a fine definition for that. But now I want you to think beyond that. And what a perfect cube or a perfect square is any expression, not expression, which yields a rational answer. Okay? So you're used to seeing natural numbers under there, right? But now you have to open your minds a little. For example, 1.44 has a square root. It is a perfect square. Its answer is 1.2. Because 1.2 is rational, this is a perfect square. Is everybody good? Now, this doesn't really come into play that much in our studies. This is the important ones. But I want you to be aware that just because this is a fraction or a decimal doesn't necessarily mean it doesn't have a perfect root. Is everybody cool? All right. Turn the page over. You can read that. Yes? The decimals? I'll show you, don't worry. But first, we are going to do something else. All right, now, how many of you have your times tables memorized? And when I say memorized, I mean memorized. I can say any two digits from 1 to 12, and by the time the last phoneme of the second word is out of my mouth, you have the answer. Not this. What is 7 times 8? 56. Not that. Not that looking up thing where you search your brain for the answer. You can do it staring me right in the face, and by the time the last sound of the second number is out of my mouth, you have already said the answer. How many of you are at that level?
I was at the level of grade 5.
Okay. No, it's not a put down. I'm asking. Okay? Yeah, people are feeling good about it. Okay, you ready? 4 times 9. Too long. 5 times 12. Not bad. 8 times 7. Not bad. 6 times 4. Okay, you're pretty good. What? Okay. Why did you do that? They told you it was important. Why do you think they told you it was important? You use it a lot in higher level math. Now let's pretend your brain is a computer. Just pretend, right? When your computer is doing a crap ton of things, what happens? It slows down because it is using resources to do a bunch of stuff. Yes? So, your brain does the same thing. If you have to think about multiplication, that is taking up brain power from the math that you have to do. That is why you memorize stuff. Okay? Now, since none of you actually care, and what your answer was when I said, why did you memorize it, was because the teacher said it was important. What's the teacher saying right here? That what I'm about to ask you to do is important. Okay? So all of you are going to do this. Even though the real reason is so you don't have to waste brain power later on. So let's do so. List the perfect squares from 0 to 400. Do I care about the decimals? No. So we will put the squares on top and the roots on the bottom, because the roots are what grow into the squares. That's my Mrs. Bad Crumble moment for you all today, okay? So, the roots are 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to run out of room because I didn't space effectively. Don't make my mistake. What are the squares? What's 0 squared? 0. 1 squared. Then what? 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 Ah, I gotta change colors. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Go. What's this one? 121. What's this one? Then what? 169. Then what? 196. Then what? 225. Then what? 256. Then what? 289. Then what? 324. Then what? 361. Then what? 400. Now you should have noticed there's a pattern here. Every perfect square goes up by the next odd number. So 0 plus 1, plus 3 to get 4, plus 5 to get 9, plus 7 to get 16. So this was plus 39. So you already know what the next one is, don't you? It's going to be plus 41, right? So the next one, if we were to continue, would be 441, and that would be 21. Everybody cool? Now, I want to call your attention to a few things here. Please notice that 100 and 400 share 20 and 10, right? 400 is 4 times bigger than 100, but its square root is 2 times bigger than this square root. That should tell you something, right? Everybody see this? Right? Numbers do stuff like this all the time. The more you see those connections, the easier math is going to be. Everybody cool? Now, the more you know, the better. But if you know up to there, you're in real good shape. So let's do the cubes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the cube of 0? It's tricky. 0. What's the cube of 1? 1. What's the cube of 2? Cube of 3. Cube of 4. Cube of 5. Cube of 6. 216. Cube of 7. 343. Cube of 8. 512. Cube of 9. 729. And cube of 10? 1,000. Now again, just another thing that you can memorize, except this one, unlike the first 100 digits of pi, is actually useful. For some strange reason, we give you guys gold stars for memorizing the first 100 digits of pi, which is completely useless, and yet something that is very useful like this, nobody talks about. How many of you had a pi contest in elementary school? Be honest. 3 only? I'm glad that's falling out of favor. All right, now we are going to talk about what this becomes useful for. Cast your minds back to your entire experience of that symbol. What do you do when you see that symbol up till today? You would punch that into your calculator, yes? All right, now, later on in life, that might not be the answer. That might just be part of the answer. You picking up what I'm putting down? Let's say you had a whole string of mathy. You've had to punch 87 buttons in a row on your calculator. Let's pretend. Then, at the end of those 87 buttons, what button did you push? Equals. And whatever your calculator said, what did you do? You wrote it down as the answer. Answer. And your teacher marked it, and because it was an elementary school teacher, she said, or he said, that's not quite right. Can you go back and have a look at that? And you would say, okay. I don't do that. Because not quite right is the nice way of saying what? Wrong. Now, I don't mind you being wrong. I am wrong sometimes. You will find in the course of our time together that I am wrong on a fairly regular basis. That's okay. What isn't okay is when that wrong answer is idiotic. Okay? Your calculator tells you what? Whatever you tell it. If you tell it garbage in, what do you get? Garbage out, GIGO. You all have heard that in some computer course at some time. You've also heard WYSIWYG. What you see is what you get. Now, the reason I'm showing you this, and we are taking this whole block to do this today, is because later on in math, when you are faced with this, I don't want you to do mathy, answer, and have it be garbage. So we are going to talk about what we can do with these values to help us do a better job of mental math. So when we do mathy on our calculator and we hit equals and the answer is idiotic, we don't write it down. Clear? All right. I'm going to show you how to do the first 3. You are going to do the rest of page 34, and that's all I'm going to ask you to do for homework. Actually, I'm only going to do the first one. Is the square root of 72 perfect? No, it is not, because it is not on our list, yes? It is between 64 and 81, correct? What's the square root of 64? What's the square root of 81? 9. Now, it makes sense that if the 72 is between 64 and 81, the root must be between 8 and 9, right? Okay. How far is it from 64 to 72? 8 steps. How far is it from 64 to 81? 17. I'll wait for while my pre-dip class does subtraction. 17. What fraction is that very close to? It's very close to 1/2, correct? So logically, what is the square root of 72? 8.5. Now, if I go to my calculator and I do the square root of 72, what do I get? Oh my good gravy. 8.5. Now, if that was one step out of 72 steps, it might be nice in my head to know that it's about 8.5. So you could do a whole bunch of mental math in your head using either 8 or 9 and come up with a good guess for what the answer might be before you go mathy equals. Everybody understand? Your job is to do B, C, D, E, and F. Now be smart. What do you notice on D, E, and F? You're using a different list, right? That's your job. That's all you have to do tonight. That's it. So easy. You've got to do some adding and subtracting. I have faith that you will all handle it well. Go.